Good morning and welcome to Monday of week 2 of your Physics 5 a day. Today is the second day of motion, which means it's time to get into the equations of constant acceleration. And we're starting today with motion in 1D. So it turns out that if your acceleration is constant, then your motion can be described with only 5 variables. The first 4, notice, are vectors. So direction is very important in these calculations. Here is the set of the 5 equations of constant acceleration. Notice that each equation has 4 of these and it's missing a different one. So for example, the first one doesn't have S, the second one doesn't have T, and so on. Each is missing a different one. Okay, so motion in 1 dimension means motion along a line. That line can be any direction you like. So for example, constant acceleration along a horizontal line might be a car accelerating forwards with a constant acceleration. Acceleration along a vertical line, that might be, for example, a fairground ride accelerating upwards with constant acceleration, or a tennis ball falling downwards with the acceleration of gravity. Or it could be acceleration down a slope. So there is your line. So it's acceleration in that direction. It doesn't matter as long as the acceleration is constant. So in each case, you have an object that, let's say it starts here, and it has some initial velocity u, and then it's going to accelerate for a time t, and then at the end of that time t, it will have a final velocity v, and it will have a displacement of s from where it started. So let's see how this works on a question. Pause now if you want to have a go at it yourself first. Okay, so here we've got a bird that is going to fall vertically downwards. So that this is going to be motion along a vertical line. We're about to list our variables here, but the very important thing we must do first is we must choose which direction is going to be positive. Now, seeing as I've got my gannet going that way, I'm going to choose down as positive. It doesn't matter, so it's up to you how you do it, but I'm going to choose down as positive for this one, and that affects what I'm going to write here. So my bird starts there, and then it moves that way, 30 metres that way, and then it hits the water. So S is plus 30 metres. It is falling from rest, so that means that U is 0. We're asked to find the speed that it hits the water. So if this is where it starts and that's where it finishes, it has speed here is U and the speed there is V. So V is the thing that we're trying to find. And we're told that it's falling and that we can ignore air resistance. So that means that there's our bird, we've got gravity acting on it. So the force of gravity acting on it, no air resistance, it's not pushing itself downwards, the only force is gravity. And remember that if that's the case, your acceleration is 9.81 meters per second squared downwards. Now we can see that we do in fact have constant acceleration here. Next we select the equation that doesn't have t in it, as that's the one we are neither interested in nor have. Put the numbers in and then square root to get the velocity, rounding to 2 sig figures.